This is a Bluetooth oscilloscope made with nRF52. We are using Feather board nRF52 by Adafruit. This Bluetooth oscilloscope has extensive applications, especially in IoT applications when we want to use low power or battery powered sensors and send the data back to the base station. To test the functionality of the oscilloscope, in this demo, I have generated a square pulse wave with one of the pins of the nRF itself. And in the breadboard, I do two things. One is a straight loop back to one of the ADC pins, and the other one is using a low pass filter by a simple RC filter to create some settling behavior to the square wave pulse. In the GUI, I can select which ADC channel is shown. For now, I just have selected 4 ADC channels. This is channel 0 that is showing the square wave pulse, and channel 3 is the one that the pulse after a low pass filter is connected to. You can see I'm seeing the square wave pulse plus the low pass filtered version. We have another example that I will show in the end when I simply connect a DC voltage, which I generate by connecting a resistor ladder to a voltage. And I show how effective this oscilloscope can be when we want to detect signals at very low powers, use battery powered devices, and send the sensor data back to the base station. So first, I'll go over the code, both the hardware code for the nRF52 and then the Python code to interact with the Bluetooth. And finally, I'll show another demo. Before moving on to the hardware implementation, I just wanted to show what is the board that we are using. This is Feather nRF52. This is a very useful board because we have the IC itself, nRF, and all the necessary supplies or regulators that we need are provided in this small board. You can see 6 ADC pins are here, A0 to A5. This means that we can connect 6 different voltages, 6 different sensors to this board, and send their information back to the base station when we want to, for instance, make a smart home application, or in a factory use different sensor information to decide the next step. Also, we have a battery connection. We can connect the battery to this board. So I really found this board very useful. Plus, it's a very cheap board. We can use different methods to program the hardware inside the nRF52. But for simplicity, because we are not doing something very fancy here, I chose Arduino and a library that Adafruit provides to communicate and implement all the Bluetooth communication with nRF52. For the interest of the time, I'm just going quickly over what is needed to make this Bluetooth communication in Arduino environment. But please comment down below for any part that you wanted I go into more detail and create another video for it. This is our first Bluetooth setup here. I made for this is the oscilloscope, but I plan to create other types, for instance, actuators or PWM modulators, so we can also drive a motor or something with this Bluetooth. So there is a simple tutorial on how to install Adafruit BLE for this device in the Arduino, which can be found in the Adafruit website. I'll put a link for it down below. But once we install the library, what we need to do for this simple Bluetooth setup is first we need to include the Bluefruit, which is the main file that has all the functions implemented. Then there are a few things we need to do to set up our Bluetooth. First, there are a couple of things, for instance, peripherals, bandwidth. We can set them to maximum if we want to maximum for the highest data packets. Then we can turn on the Bluetooth hardware by just bluefruit.begin, which essentially turns on the Bluetooth chip inside the nRF. We can set the name of the device. We can set the TX power, and also some other things, for instance, the communication update. This is essentially the polling, or when the time that is waited until we read the next cycles. You can play with these numbers based on the application that you want. Once this is done, we just need to enable BLEUart, which is essentially a virtual serial port Bluetooth that gives us the ability to treat this BLE as a UART device. We can simply write or read to this device, which basically sends or receives information. There are some handlers. For instance, we can define handlers by setting set connect callback or disconnect callback. These handlers are called when we first have a connection, or if a disconnection happens. In these handlers, we can specify what is the next step, for instance, after we connect or disconnect. Another thing which is not related to the Bluetooth, but also this chip, this nRF52, has several ADC channels inside, and when we want to just use those ADCs inside the Arduino, we can, for instance, set the resolution. We can say analog resolution to 12, meaning that we want to use the 12 bits. And then once this is done, all of the Bluetooth and ADC, we just call a start advertising function, which essentially enables the Bluetooth advertisement. So what is advertising? Advertising essentially lets other devices in the environment know your existence. You can also add information to your advertisement. I have added two information. One is I say this is a general discoverable mode. And also I have added information saying that this is a Bluetooth low energy device. Some other features for classic Bluetooth are not supported. So a device search, when a device wants to connect to this device, search it, they find its name, they can see the flags that are being advertised. And then I have another one, which is a service, meaning that I am adding a service to my Bluetooth device. So when the advertisement is happening and a device gets connected to my device, this service helps me to send or receive information through this device. Now, the final step. I have advertised, someone got connected to me, and when got connected, the service got added to my Bluetooth. So now I can simply read and write like I do for a UART port. I just say, if there is a data available, just read it and put it into C, which is basically reading character by character. Then I can do a write basically by printf function or any special printf function. I can create a string and then write it in my BLEUart, and that's it. This is as simple as it gets. I just mentioned the very essential steps that we want to do to create this Bluetooth in the Arduino environment. But as always, I'm putting all the codes both for Arduino and Python into the channel GitHub. So please go look at the code and replicate it yourself, and please comment down below if any part that you want more details. Now let's talk about the Python side. This project is very useful because it gives us the ability to communicate to a Bluetooth device using Python, and we can use this to create all sorts of projects. For instance, we can create IoT sensors, read the sensor information, process it, and based on the information make a decision and send the decision back to the actuators, the IoT actuators. In the Python, we use Bleak library. This is essentially a bridge between Python to Windows that handles all the Bluetooth low energy functionalities for us, and also Windows will handle the hardware, Bluetooth hardware of the PC. So we need the scan function. We use inside the scan function, we use Bleak scanner.discover to discover any Bluetooth device in the environment, and then for each of these devices we add them into a drop-down menu. So in the oscilloscope GUI, we can select which device we want to get connected to. Then in the connect function, based on the device that is selected in the drop-down menu, we try to get connected into it. So one interesting thing is that once we get connected, we can use a start notify, which basically subscribes to the Nordic UART characteristics. So whenever our nRF52 sends any data, we will get notified. It acts like a interrupt for us. So we get notifications that saying that, okay, there is some information for you to read, and then we can just read that data. Inside the notify, as I mentioned, it acts like an interrupt when we subscribe to the TX characteristics. Then basically this notify is called whenever we have data, and then this data is sent back to us, and then we add it into our buffer, and then also increase the length of the buffer information based on the number of data that we received. So this buffer contains all the informations that is sent from the nRF52 to Python, which has the ADC voltages that are sent from nRF52 to Python. We can also do write. Again, we need some characteristic informations that are hard-coded for nRF52. Then we can simply use this write get char to write data to the client. So this is as simple as it gets, using the Arduino and also this Python piece of code. We can create a channel between our hardware nRF52 to Python. For this project, we just read back in Arduino, we just read all the ADC information. We create a string from those information and send them to the Python. Python here receives them, processes them, and then shows them into plot. Now that we saw the Python implementation and also hardware implementation using Arduino, let's go back into the application, the GUI, to see some of the things in action. So we have the scan function here. This calls the scan function in Python. If I just press scan, it scans for the Bluetooth devices. I have added a filter saying that just show the Feather devices in the drop-down menu, which we only have one here. And once it's discovered, I just say connect. So I change the sample rate here. You can see first the plot, the square wave is different compared to the next cycles. That is because it takes some time for me after the connection. I change the sample rate to the maximum, which is 1K. So that's why the plotting changes. But I can clear the plotting. I can pause the plotting. I can add markers or change the zoom. I can clear the market and other functionalities. So one other thing is in this application, we can select the channel of the ADC that we want to see. I can select ADC 0, ADC 1, 2, 3 here. Here we just have 2 subplots. And I want to show another interesting feature. So you can see this is the square wave, but to also show the capability of the oscilloscope, I have created another set of voltage, which is basically using a resistor ladder here. I have a resistor and a variable resistor that create a variable DC voltage at this node, and I'm feeding it to channel A1 of ADC. So now if I come here and change the variable resistor value by just turning this knob, you can see the amount of DC voltage that we are reading changes accordingly. And this is very close to, I checked this with a voltmeter, and the accuracy of 12-bit is giving us a very good accuracy to read any of these DC voltages. This is very useful because this nRF52 can be employed in the applications that very low energy is needed. For instance, battery-powered IoT sensors. We can create sensors with this nRF52 that can last over a year with just a simple coin cell battery, and read any sensor information and send it back to the main base station we have by some intervals. So there you have it. This is our oscilloscope using nRF52 and Bluetooth. I will create another project to make the other part, which is actuating a device, for instance, controlling a motor or turning off or on a switch. Please comment down below which part of this project that you want me to go into more detail. And also, please go and download this project via our GitHub channel and give me any feedback. Thanks for watching.